So, hey everyone, my name is Arnab Bhattacharya, and today I'm going to talk about my app, Purely, which is an agentic application to help improve your technical writing skills. But first, a bit about me. I'm a senior engineer working in the domain of operations research with a PhD in mathematical optimization and have over 8 years of experience in working and leading R&D teams in academia and national labs. So trust me when I say this that technical writing, as much as I love it, is hard. And part of the reason is because there are six essential elements for a well balanced research article. First, it needs to have clarity, which means any kind of concepts are easily understood. It should be concise, be direct, and also to the point. There has to be correctness, where you are presenting accurate findings. It has to be consistent in styling, nomenclature, and also tone. It has to adhere to ethical standards. And finally, it has to be rigorous, which means that you have to provide thorough, evidence based explanations and demonstrate domain understanding. Now, if you're a unicorn who has mastered the full research to communication pipeline, who does fabulous research and have also experience in applying this writing construct effectively, then you're in the land of research utopia. But for many researchers, real life is far from a fairy tale. Balancing multiple ideas while trying to write can feel overwhelming, especially for beginners. With looming deadlines for conferences or grants, language barriers for non-native writers, the challenges intensifies. Meanwhile, mentors and peers may be too busy to provide feedback, leaving writers to navigate this solo and often resulting in less than perfect work. Next comes the challenging peer review cycle, where researchers often face slow processes that may take weeks, months, or even years. Common issues include reviewer bias, slow progress, and unhelpful feedback, which could have been mitigated by understanding key writing principles earlier during the writing phase. So, researchers encounter significant gaps in the writing process as tools like Grammarly or spelling checks only address surface level errors while lacking understanding of domain-specific issues like flawed math, incorrect definitions, irrelevant references, and many more. Domain experts are too busy to assist, and by the time peer reviewers catch fundamental problems, months have been spent on flawed manuscripts. Finally, unlike coding with linters, debuggers, and also coding agents, writing lacks early warning system for errors. So what's the solution? Introducing to you all Peely. Peely is an agentic co-reviewing assistant that offers on-demand context-aware suggestions for technical writing. It employs a specialized team of AI agents to identify various issues ranging from clarity to rigor around the clock 24 by 7. It utilizes RAG and a curated set of domain-specific guidelines where it delivers targeted suggestions to enhance the research artifacts. And finally, it features an integrated platform where researchers can write in LaTeX directly, access AI agents, and receive instant feedback all within a single interface. This tool was actually created with the research community in mind. Appeally is designed for anyone conducting and publishing research, regardless of industry, the stage in the career, or type of research writing needed. This employs users by allowing them to control the editing process by receiving expert AI assistance. Users write in a LaTeX editor and can trigger the AI analysis for feedback, selecting specific agents as needed. The AI identifies issues and suggests fixes with clear reasoning, but does not make any invasive edits. Ultimately, users review these suggestions and decide how to proceed, creating a continuous feedback loop. Now, let's look at a quick demo of PLD. This is the landing page of the application. So first thing we'll do is we'll upload some files. Let me click upload files, or actually let's open up a new file here, computing.txt, load this file. So you see that you have the LaTeX editor and the PDF preview in the same place. And this file is again like not very polished. So it's just talking about like a quantum algorithm for graph problems. And the application should find a lot of issues, and that's by design because this is a demonstration. So the real important thing here is we summon the AI insights. This is where you choose your agents. So right now we have the clarity and the rigor agents, or you can run both the agents in parallel. So I run the analysis and it finds 39 errors. So 30 issues were found by the clarity agent, 4 were found by the rigor agent. And they have different degrees of like severity. So the red ones are highly severe, the yellow ones are warnings, and the blue ones are just like informational. And these issues are specified per section. So if I go into the introduction, you'll see that there's an error on a particular line. So in this case, it's saying the term like quantum superposition and entanglement in line 28. So if I go to line 20, it says that it's not really clear. It also gives you a suggested fix, but it's not going to do any invasive edits into your application. So it's up to you. Um, it also gives you an explanation why it feels like that way, and it gives a score. So this is your like score of how much the LLM thinks that what is the degree of like severity of this issue is. So you can look into other sort of parts as well. So for example, if I look into this theorem, which is a little bit more math heavy, uh, it says that this theorem a 58 states claim without providing any proof or justification, and gives you a suggested fix, the shift operator and the state, detailing the functions with the quantum box. So it's understanding a lot about the domain that you're working in. So it's not giving you very generic sort of fixes or any kind of like suggestions. Okay, so let's go back to the slide. Let me quickly explain the system architecture for PLE. So what you're seeing in here is that you have a front end, a back end, and a vector DB service based off quadrant. So in the front end service, you have the LaTeX code editor. It's based on React, Vite, and also Code Mirror. What we do here is we write our file, and then you have the section parser, which parses all of the text, which is then sent into the orchestrator agent. And the orchestrator agent has a routing logic that sends some parts of the text to different type of agents. So in this case, you have your clarity and your rigor agent. Uh, for this example, you want to send all of the text to the clarity agent, but maybe only the math heavy sections to the rigor agent. They have access to their rack pipelines. You have your like embeddings, which are essentially the guidelines for which both these agents are using to like are being provided, and then finally sends it back to your like suggestions parser, and finally to your front end. And we have a LM inference provider here. So I'm using a GPT-5 mini for this application right now, but there's also a way to sort of like run this application, and it can be quite costly over and over again if there's not a lot of variation in terms of what you've added into the text. So finally, in terms of the next steps, I have 4 main steps here. The first one is that we want to hook it up to this open source model, so that you are also like you're like catering to concerns about privacy. Expand the agent's library. Uh, then have like a chat where you can, while you're writing, you can also ask more sort of contextual questions. And then finally, to have some sort of like integration with different like references and also like bibliographies and stuff to help add these to your document much more easily. So yeah, with that, I'd like to stop here and thank you for being part of the presentation. I appreciate your time. Thanks.